Welcome back, everybody. In this video, we're going to be taking a look at a dual DMVPN hub. Uh, Acts like a LAN segment over a publicly available transport, just like we saw in the single hub. Considered a single point of failure in the case of the hub fails if it's a single hub. Hubs are normally connected to each other via DMVPN as well or static GRE tunnel. We're going to configure a dual hub connection here. We'll go ahead and pull up the config here. We're going to do this on 15 to 11 and 8 and get those guys running. And basically, we're going to take the configuration, roll with it, and make sure everything comes up as it's supposed to. And then we'll take a look at some of the minor details at the end, because it's not going to take us long to get this hub up and running. And then we'll take a look at the differences between phase 1, 2, and 3 and how that comes into play. So from a topology perspective, we're going to jump on 15. I'm going to go ahead and exit out real quick, and I'm going to type in interface tunnel 101. I'm going to type in the tunnel source is going to be 15.17.0.15. The tunnel tunnel mode is going to be GRE multipoint. The IP address is going to be 10.1.101.15/24. And I'm going to type in the IP NHRP map multicast dynamic. The IP NHRP network ID is 101. The tunnel key is 101. And the IP NHRP, we're going to specify the authentication. In this particular case, is going to be CCNP as well. And do show run interface tunnel 101. Pretty straightforward config. Pretty much identical to what we saw in the previous video. We're going to go ahead and configure 11 to do the exact same thing. So instead of us doing it, we're going to basically take and we're going to mirror this config. I'm going to take this config right here, and I'm going to tweak it a little bit. So over here, and take this guy right here. I'm going to say 101. This guy's going to be 101. This guy's going to be 101. The source in this particular case is going to be 17.11.0.11. We're going to map to 10.15, and it's going to be a 15.17.0.15, and then 15.17.0.15, and the source, all of that looks pretty good. We're going to bring this guy to be 101, and this guy's going to be 11. And pretty much do this right here on router 11. And then router EIGRP 1, we're going to type in network is going to be 10.1.101.0/24. Same thing on router 15. So router EIGRP 1 network of 10.1.101.0/24. Gets our adjacency up here. 11 should have one as well. Momentarily anyway. What does 15 see? Do show DMVPN, and we have a problem with 11. 11 here. Oh, next hop server is wrong. So let's go type in interface tunnel 101, and the next hop server is incorrect. We need to make this 101.15. And no, and there's a EIGRP adjacency right there. We're going to pull this guy out, and we're going to say that do show run interface tunnel 101, and we're basically going to take this configuration and just replicate it over to router 8. Just replace this with that, and going to make this .8, and everything else looks pretty good. Take that information right there, go to router 8, and exit out, or actually let's go ahead and type in network of 10.1.101.0/24, exit out, and then copy and paste this guy in, and then the tunnel will come up. The tunnel source needs to change to be 8.16.0.8. That'll fix that problem. Yep, and we're going to go ahead and shut the link down just to anytime you get a packet error, stuff like that, it just makes it a whole lot simpler just to flap the link. Same thing with MPLS traffic engineering. It should automatically resignal, but sometimes it does give you some bugs. Go from there. So now that we've got EIGRP should be up here momentarily. Let's see, 15. I'm always impatient at this point in time. We have okay, so this time I wonder if, because now it's saying it's behind a NATA device. I wonder if that's because it's signaled with that address. That's why. I wonder if that's why it's working that way. On 8, if we do a do show DMVPN, yeah, it originally signaled with that. So if we go, I'll fix that. I think I know what the problem is here. On 8, if we do a do show run interface tunnel 101, we originally signaled with 15.7. So I'm actually going to say, I'm going to grab this information right here. I'm going to say no interface tunnel 101. I'm going to go ahead and blow it away. And then I'm going to go ahead and re-signal with that. Give that a second or two to come back up. And it says that there's a unique address already there. So 15 should have... Okay, so let's go ahead and jump out here and do a clear DMVPN session interface, and this is mapped to interface tunnel 101. Interface tunnel 101. So let's go ahead and just clear that out. And I'm going to do the same thing for 15, which I believe on 8 we're seeing do show DMVPN. We're seeing this for 14. So on 14 we're going to do the same thing. We're going to say do show run. Let's go with no shut. And I'm going to go ahead and let the tunnel come back up. And do show run interface tunnel 100. I'm going to say no interface tunnel 100. And I'm going to go ahead and say, just recopy it back in. And actually, let's go to router 8 and type in do clear DMVPN interface tunnel 100. Clear DMVPN session, interface tunnel 100. And then on 14, copy and paste that bad. Oh, that's not what I meant to do. No interface tunnel 101. I want to grab this guy right here and reapply. Because the problem we're having here, and I didn't realize it at first until I looked at it in a little bit more detail. The problem that we're having is when we configure it, there's the adjacency on 14 now. If we go back to 8, we do a show DMVPN. The problem that we're having is when we configure it, we were signaling with the source of another spoke's address. So what ends up happening is when you have that situation occur, you go out, you set the source IP address to be another spoke's public address. So what you're basically saying is, I am behind him. So that's why the NAT came in the way that it did. And 11, we are waiting on 11 to come back in. Let's see here. Do show IP interface brief. interface tunnel 100 shut, no shut, and then 101 shut. It's better to wait until the connections flap and then bring it back up. Because the moment you see the tunnel go down and then come back up, now we have the adjacencies. Now 8 should see everybody connected that way. And then we have, that's good. Now 15 should see multiple adjacencies. Show DMVPN. And we're waiting on 8 to come back. So let's go ahead and now it's 8 for 15. And we're waiting on router 8. So let's go to router 8 and go to global config. Do show IP interface brief. And that was tunnel 101, correct? Let me just make sure I'm going too fast here. Tunnel 101, yep, on router 8. I'm going to type in interface tunnel 101. I'm going to go ahead and shut the interface down to resignal it. And then no shut the interface to bring it back up. That's going to resignal. And that should have all been all it took right there. So then we go back over to 15. We hit the up arrow. And we are completely peered again. So this means this is a good sign. So everything's working the way that it should be. And we are in business. Now remember we said 8 and 15 are our 2 hubs, right? So we have our 2 hubs configured. Everything looks pretty good from this perspective. And we're learning the configuration the way that we are. Now, does it matter which way we look at it? It's really up to you and how you want to interpret the results. So the results are we have active adjacencies going back and forth. So 15 is acting as a hub for routers 8 and 11. And router 8 has do show DMVPN. We have routers 11, 14, and 15 as spokes in our configuration. And 15 is a hub to router 8. Or sorry, router 15. So that's basically how you would interpret this. So let's go ahead and I'm going to go ahead and break down to you guys what phase 1, 2, and 3 are for DMVPN. Break that down, and then we're going to take a look at the concepts of there's normally what you're going to do is, and I'll break down the hierarchical aspect of DMVPN, which you could in some way say we're doing that now because 15 is a spoke of 8, and if 8 failed or something happened and 8 needed to get across to 15, they can get you to router 11, stuff like that. So phase 1 is going to be spoke to hub to spoke. Okay, that's basically how this goes, and it's the traffic always has to go through the hub in order to reach another spoke. That is just how it is. There's no getting around that. That is you basically are doing on the spoke, it's a point-to-point connection. On the hub, it's a point-to-multi-point connection. And on the other spoke, it's a point-to-point connection. The point-to-point connections are both pointing to the hub, which is a point-to-multi-point connection. Okay? This is where you can do summarization. If you're going to do EIGRP like we are, nothing really going on. OSPF, this is typically going to be a point-to-point and a point-to-multi-point style configuration. The point-to-point goes on the spoke, the point-to-multi-point goes on the hub. For phase 2, this was the second iteration, and this is basically you turning off the next hop self command. And with the next hop self, and this was EIGRP, was how you would enable that. So you would do that in EIGRP, and that would say, don't use the hub as the next hop, and go out and ask for what they refer to as a next hop request and resolution. It's going to go out there, and the spoke is going to ask the hub, how do you get to this IP address? The hub is going to do an NHRP lookup in its database and then respond with the next hop information. And that's how you would go about getting that done. OSPF, this is going to be a broadcast network type. So you simply say broadcast, everything would be working out at that point. Phase 3, which is the one that most people want to use, which is spoke to spoke. This is also allows spoke to spoke communication, but the first packet has to traverse through the hub. So if you went through and you did a trace route or a ping, you would see the spoke or the hub in the first trace route. But in the second trace route, once the secondary tunnel was built between the spokes, you would see just spoke to spoke communication. This is where you, for EIGRP and for OSPF, you would use the redirect command on the hub, and you'd use the shortcut command on the spoke. Redirect would be a quicker way of looking up the next hop information for the spoke talking to the other spoke. For EIGRP, nothing. You would re-enable this command, the next hop self. You would say, you know what, don't worry about that. That's phase 2. For phase 3, you would re-enable this command and let NHRP do it. For OSPF, you would run point to multi-point network type on the spokes and the hub, so that it would have communication with both. And that's phase 3. Now, there is a newer way of doing this. So this is DMVPN, again, is just a routing technique, right? So we could go in here and get these guys up and running pretty straightforward. Everything would be good to go. There is a newer way of doing this, and it leverages internet-based routing as well, and it is referred to as Locator ID Separation Protocol, or LISP. LISP is the newer and improved version of DMVPN. I like to refer to LISP or DMVPN phase 4 as, or I'm sorry, phase 5 as LISP. The reason I say that is because with DMVPN, all you're doing is allowing a point to multi-point communication over a GRE tunnel, but you still have to run some sort of routing protocol over the tunnel in order for routing adjacencies to get shared. With LISP, it does UDP over IP, and it forms the tunnels automatically. There's a mapping server and a routing locator and what they refer to as an endpoint ID. So you get all these things that you map to. And so the routing locator is basically the site. The endpoint ID is the host that you're trying to get communication to. And the mapping server is pretty much like your NHRP server or your hub in your DMVPN hub and spoke design. LISP is the newer iteration of all that, and it's gonna I think eventually replace DMVPN. DMVPN is very, very scalable. Now, phase 4 for DMVPN is what I like to refer to as IWAN, or the Intelligent Wide Area Network, where DMVPN is the logical construct that is built to provide the end-to-end connectivity over any media, regardless of what it is, MPLS, internet, what have you, and then you use performance routing, PFR, v3 specifically, for communicating between the hub and the spoke to know what's where and how you're going to route to it. That's what I refer to as phase 4. So IWAN, in my opinion, is phase 4. This is just my opinion. This isn't technical, factual information. This is just basically how the protocols work. So PFR v3 gives IWAN its capabilities. DMVPN allows the communication so that PFR knows to point to a particular connection, and then you're able to get the communication back and forth between the endpoints. So whenever I make I consider PFR kind of like your software-defined WAN, where when I'm on the IWAN hub, if you will, this is going to be the master controller at the master site. Whenever you make a change on the master controller, that update is replicated to all of the other routers and the IWAN, what they call domain, or the default domain. So there's a lot to this. I'm going to take a look at this. I've actually got a small proof of concept working for a customer that I'm working with now. I will be showing you guys how to do both IWAN and Lisp in CCIE route switch. And that is one of the reasons why we're going to take a much deeper look at it, because Lisp and IWAN don't require a service provider to be in play. You can, actually, that's not 100% true. Lisp is typically going to be used by the service provider, where you're going to map to the service provider, but it's not necessarily required. So there's multiple ways of doing it. You can use a mapping server at a hub location at an enterprise. That's probably how we're going to roll it out. But we're going to take a look at how Lisp and IWAN come into play when we get into CCIE for the VPN section. We're going to do obviously MPLS and then do stuff like that. What I'm going to show you guys in the next video, since we've broken this down, is I'm going to go ahead and show you guys how to roll out the crypto to these tunnels and get them situated and go from there. Until next time, guys, take it easy.